أعزائي طلبة وطلبات شهادة الثانوية العامة قسم الرياضيات، أهلا بكم. وعرفنا طبعا الدرس الماضي كان على القانون الأول. النهارده إن شاء الله هناخد القانون الثاني ومسائل عليه. Welcome my dear student in our math program for second 3. Dear student, today we are taking new lesson. Its title Newton second law. Dear student, look at the second Newton law. What do you mean of the second Newton law? The rate of a change of momentum with respect to b time is proportional to acting force and take place in direction in which the force is acting. Look at, dear student, d over dt mv is varies directly as the force F. This mean or mathematics mean of second Newton law. d over dt, change of the rate of momentum mv, m mass, v velocity, is varies directly as the force F. Look at this equation, is very important. d over dt, change of the time, mv, varies directly or proportional at the force F. Then d over dt mv equal kf. Why? Because the relation varies, we replace it with equal constant k. Then d over dt equals mv equals kf. K is proportionality constant. As the mass of the body is the constant during motion, then m times dv over dt equals kf. Dear student, in this case mass is constant, then change v respect to time times m equal k proportional constant times f force vector. K is proportionality constant. Then what you deduce? We deduce that m times acceleration a equal k times force vector f. Why? Because a acceleration vector equals change of the velocity respect to the time. Remember, dear student, dv over dt equals acceleration a. If we define the unit of the force as the force if it acts on a body of mass, a unit of mass. Is occurs the body, the unit of acceleration. By substitution in equation above, we find that 1 equals k times 1 times 1, then k equals 1. And the equation above takes the form ma equals f. This is the second rule of Newton. This equation, what you mean? M mass, A acceleration, if product, if M times A, the answer is the force which act the body which mass m. This equation is called equation of motion of constant mass body. This is considered the basic equation of dynamic. This is very important. It is considered the basic equation of dynamic. ma equals F. It can be applied on all the moving body on constant mass of consider such bodies physical points. From the equation of motion, we find that F and A are measurable. Fa measured in a certain direction, it is necessary to measure F in the same direction. So, it's better to write down the equation of motion in the form ma vector equals F vector. If A and F express algebraic measure of each of A and F respectively, then the equation motion of constant mass body is written in the form ma equals F. This equation of motion constant m, it's written in the form ma equals F, where m is the mass of the body moving and the acceleration of motion, and F is algebraic measure of resultant of the system of the force acting on the body. Therefore, ma equals sum of the forces. But the mass m, if variable, not constant, then what you deduce? The equation of the motion is written in the form, what is the equation? F equal d over dt kv vector. Dear student, in this case, the last equation F equal ma or ma equal F. In the case m is constant, mass is constant, but in this case m is variable. Then the force equals differentiation of kv vector. We deduce sum of F equals d over dt mv. Equation of the motion using differentiation. Look at, dear student, the equation of motion of constant mass body is given in the form mf. Dear student, in this case, dear student, we use differentiation to find the value of acceleration or the value of the force which act on the body. Remember, dear student, we have two equations of the motion of the body. In dynamic, this basic of dynamic in equation of when a body is moving with acceleration A, we use F equal ma or ma equal F. In this case, m is a constant, but if mass of the body is variable, what is that deduce? We deduce that the force equal m or k d by dt d of the velocity v. Remember, we have two equations. The first equation when mass is constant, the second equation when mass is variable. Mass is constant, therefore ma equal F. But when the mass of the body is variable, we use F equal d over dt kv. Dear student, look at the following. The equation of motion of constant mass body is given the form ma equal F. Fa equal dv by dt, then F equal m dv by dt. Integration of f dt from t1 to t2 equal m integration v1 v2 dv. F a equal d, the acceleration a equal v dv over ds. Remember, dear student, we have acceleration a equal dv by dt and a equal v dv by ds. Then by substitution about the equation f equal ma, the equation is f equals mv dv over ds. Remember, dear student, dv over ds, what you mean? We find differentiation of the velocity respect to the distance or displacement. Then integration from t1 to 2 f ds equal m constant integration from v1 to v2 dv. Look at, dear student, we have very important equation. Integration f ds equal m integration dv. If the mass is variable, the equation of the form takes the form f equals d over dt mv. What it use? Where h of m and dv are differentiability function respect to time t. Unit of the force and unit of the mass. Deduce the equation of the motion, moving body. We choose certain units for each of the force, mass, and acceleration until the constant of proportion is equals to 1 unity. Look at equation of the motion, takes the form ma equals f. What you mean? M is mass of the body, a is acceleration, f is the force which act on the body with acceleration a. As a result, when we use the equation of the motion, we use absolute unit of the force such as Newton and dyne. M times A equal F. What is the unit of M? Mass 1 kilogram. What is the unit of acceleration? Meter per second square. What is the unit of the F? 1 Newton. Then the second unit, 1 gram times 1 centimeter per second square equals 1 dyne. We have two units in the force, Newton and dyne. We have two units of mass, 1 kilogram or 1 gram. Also, we have units of acceleration, 1 meter per second square, 1 centimeter per second square. Newton is kilogram meter over second square, but dyne is gram centimeter per second square. Remember, Newton equals 10 power 5 dyne, or dyne equals 10 power negative 5 Newton. What is the greatest? Newton. Why? Newton is equals 10 power 5 dyne. Remember, the smallest unit of the force is called dyne, and the dyne is gram dot centimeter over second square. This unit of the equation ma equals f. Weight and mass. What is the difference between weight and mass? Is weight, dear student, is mass, or there is difference between weight and mass? The weight of the body is the Earth's attraction force of the body. If we have body of mass 1 kilogram, then its weight, according to the equation of the motion, is equal to 1 kilogram weight. MA equal F. Then 1 times 9.8 equals F. What is 9.8? Excellent student. Acceleration or gravity. Acceleration 9.8. Then F equals 9.8 Newton equals 1 kilogram weight. Now we are translate to example. Dear student, a force of magnitude 10 newtons acts on a body at rest of mass 8 kilogram to move it in its direction with uniform acceleration. Calculate the distance traveled after 12 seconds and its velocity. Solution. Dear student, look at, we have force 10 Newton and V naught equals 0. Why? Because the body from the rest. What you mean? When the body is at rest, initial velocity equals 0. F equals 10. We use mass equal 8 kilogram. T after 12 seconds by using equation of motion of the body. Dear student, MA equals F. Then by substitution about M equal 8, F equal 10 Newton, then we find the acceleration is equals 5/4 meter per second square. We translate into equation of motion V naught plus AT. When the body act on it force F with initial velocity and acceleration A with the time T, we use the equation of motion of the first equation is final velocity equal initial velocity plus A times T. By substitution, then V equals 0 plus 5/4 times 12. 5/4 is acceleration. Therefore, velocity equals 15 meter per second. Now we write the second equation of motion. What is the relation between this equation, displacement S, and time? Relation between S time, S equal V naught T plus half AT squared. By substitution about A and T, why? Because V naught equals 0. Therefore, S equals 0 plus half times 4/5 times 144 equals 90 meter. What you mean? After 12 seconds, dear student, displacement which the body is covered at 90 meter with acceleration 4/5. Another example. A body of mass 3 kilogram is led to fall from a height of 10 meter on a sandy ground to sink or embed for distance of 5 centimeter. Remember, dear student, body of mass 3 kilogram led to fall from height 10 meter on a sandy ground to sink or embed for distance 5 centimeter. Find the sand resistance to the body in kilogram weight, given that the body moves with uniform acceleration within the sand. Solution. In this example, very important, we have a body is laid to fall from distance or from height to embed the sand. This body has velocity and acceleration. At the first, we find the velocity of the body when moved to reach the sand ground and embed centimeter distance. After that, how long or what is the time which the body is embedded in the sand. Dear student, look at the solution of important example. The phase of free falling, what is the equation? The third equation of motion, v square equal v naught square plus 2gs. By substitution, about v naught equal 0, g 9.8, gravity force, distance is 10. The first, we calculate the velocity of the body when fell from a height 10. Then velocity equals 14 meter per second. Remember, dear student, the body is fell from distance 10 meter. In this case, the body is moving with velocity 14 meter per second. After that, in sinking or embed in the sand, we use the same of equation. V square equal v naught square plus 2as. But remember, dear student, v above the sand equal v naught under the sand. V naught square equal 14 square plus 2as. V final velocity equal 0. Why? Because the body, when embed in sand to stop, then the velocity or final velocity is equal 0. And when the body moves inside the sand with velocity or initial velocity 14, what is the acceleration under the sand? We use v square plus v naught square plus 2s. By substitution, about v square equals 0, v naught square 14 plus 2a times 0.05, the distance, then acceleration is negative 1960 meter per second square. Equation of motion is ma equal mg minus r. By substitution, about m 3, a acceleration negative 1960 equal mg 3 times 9.8 minus r resistance. What is the resistance of the sand? In this case, r equal 3 times 9.8 plus 3 times 1960. Resistance is 5909.4 Newton. This is resistance of the sand. R equals 603. Now we are translate to another example. Look at, dear student, body of unit mass under the action of 3 forces. F1 equal AI plus J, F2I plus BJ plus 3K, F3 vector I plus 2J minus EK. We have 3 forces. The first force AI plus 1J, second force I plus BI plus 3K, F3 or third force I plus 2J minus EK. If the displacement vector S is given by the relation S equals Ti vector plus bracket contains half T squared plus T J vector plus 5K vector, find the value for each of A, B, and E. Solution. Dear student, in equilibrium, sum of the all forces equal F. We add F1 plus F2 plus F3. Then A plus 2 inside bracket I plus B plus 3 inside bracket J plus 3 minus A inside bracket K equal the force F. Sum of the all forces equals A plus 2I, B plus 3J plus 3 minus EK. But we have displacement, the relation between displacement and time, its equation as Ti plus bracket contains half T squared plus T J plus 5K. In this, V velocity equals ds by dt. Differentiation displacement respect to time t is equals I plus bracket contains t plus 1 j. Therefore, acceleration dv over dt. What is the acceleration? Change of the velocity. dv over dt equals j. Then ma equal f, this equation of the motion, by substitution j equals, what is the j? Is acceleration, equals a plus 2 inside bracket I plus b plus 3 inside bracket j plus 3 minus e inside bracket k. What is the value of b? A plus 2 equals 0, then a equals negative 2. B plus 3 equals 0, then b equals 1, negative 3, negative 2, and 3 minus e equals 0. We deduce that b equal e equal 3. Dear student, remember we use acceleration times m equals a equal f by adding 3 forces, F1 plus F2 plus F3, to find the value of sum of forces. Sum of the forces equals F. After that, we find the acceleration by using dv by dt. Before we find acceleration, we find the velocity. The velocity equal displacement d over dt of displacement respect to time. We have s as the first. Find differentiation of displacement respect to time t to calculate the velocity. After that, we find acceleration by using differentiation of the velocity respect to time t. Then we form equation ma equal f by using left hand side and right hand side in direction I. A plus 2 equals 0, then a equals negative 2. In direction j, b plus 3 equals 1, then b equals negative 2. And last, in direction k equals 0, 3 minus e equals 0, then e equal 3. The constant a equal negative 2, constant b equal negative 2, constant e equal 3. Dear student, by the end of the lesson, we know the second rule of Newton, the very important lesson. This equation ma equal f. Don't forget, this equation is the basic of dynamic. Dear student, I am very happy to spend such time with you. Goodbye.